Hi everyone, in this video we are going to solve some problems of thermodynamics. All the problem statements are taken from previous year GATE examination. The first problem is taken from GATE exam 2016. It is given that isothermal compression from 5 megapascal to 15 megapascal at 400 Kelvin, and clausius equation of state is given, and where Bt is a function of temperature, the values of B0 and B1 are given. One more relation is given, this one, enthalpy as a function of pressure at constant temperature, and we need to calculate change in molar enthalpies. If I want to calculate this HF minus HI, the meaning is I need to calculate delta H, what is the change in enthalpy, and that can be obtained from this equation, because according to the statement the process is isothermal and there is a change in pressure from 5 to 15. So I know the value of 15 and the pressure change from 5 to 15 megapascal. From this equation we can calculate this one. How to solve RHS? In this case, the del V over del T at constant P, that can be solved from the equation of state, using this equation of state. So if I rearrange this equation of state, then it would be V minus Bt equal to RT over P, V equal to RT over P plus Bt, but I can write this one B0 plus B1T, and if you simplify this equation again, it would be R by P plus B1 into T plus B0. So this is an equation of V, but now I need to calculate del V over del T at constant pressure. So if we take the derivative with respect to temperature on both sides, pressure is constant, so this would be constant, so it would be R by P plus B1, because the derivative of temperature T with respect to temperature, that is 1, and B0, that is constant, it is independent of temperature, so this would be 0. This is the equation number 2. If we know these two values, we can insert in the equation of enthalpy. It would be del H over del P at constant T equal to V. In place of V we can put this value R by P plus B1 into T plus B0 minus T into this entire term, again R by P plus B1, and this will be cancel out, so only answer is B0. This is equal to B0. Now the process is an isothermal, so I can write in this way dH over at constant temperature, that is equal to dP at constant temperature. The value of B0 is given 4 into 10 raised to minus 5, and the value of dP, that is change in pressure, so 15 minus 5, so 10 into 10 raised to 6, because the unit is megapascal, I need the answer in joule per mole, so I am going to convert in Pascal, and the final answer, it would be 400 joule per mole. So this is HF minus HI. Let's solve one more problem. I have considered this problem from GATE 2018. The equation of state is given with constant B 0.029 meter cube per mole, the values of temperature, volume and moles, and the gas is methane. We need to calculate isobaric rate of change of temperature with volume. So ultimately isobaric rate of change of temperature del T with volume, so over volume, this I need to calculate. To to calculate this derivative, we can use this equation of state, means we can take the derivative with respect to volume on both sides, keeping pressure constant. But this is again B, that is also it is dependent on volume, and we don't know the relation of B and V, how means it is related with the volume. So this is little confusing. Instead of that, if I write or if I take reciprocal of this one, then it would be more easier. So here I am going to take the derivative on both sides with respect to temperature, keeping pressure constant. So here it would be del V over del T at constant pressure, but in this case N and B both are independent of temperature, so that would be 0. Here the derivative of temperature with respect to temperature, that is 1, and it would be Nr. If I take the reciprocal of this one, then it would be like del T over del V at constant P equal to P upon Nr. So how this is obtained? Just check the video of reciprocal relation, P upon Nr. Now we can again put the value equation of P nRT over V minus NB into Nr. I have just replaced the value of P using this equation. It is nRT upon V minus NB Nr. This would be cancelled. Temperature, that is given 500 degrees Celsius. Here we need to calculate the change in temperature with Celsius per meter cube. But here I am going to take the value of temperature in Kelvin. You should remember that when we are going to place any value of temperature, always keep it in absolute value, means you should take in Kelvin. I am going to put the value, and at the denominator 5 minus N is 100, and the value of B, that is 0.029. So the final answer, it is almost 368 Celsius per meter cube. The change in Celsius temperature with Celsius, with Kelvin, there is no difference, means we have taken in Kelvin, but when we are calculating the change, both are same. But when you put the absolute value of temperature, you should always use the unit Kelvin, not Celsius. Let's solve one more problem. I have taken this problem from previous year GATE exam, and that is from 2022. At 4 degrees Celsius for any substance, these are the three values given: thermal expansion coefficient, that is beta, then isothermal compressibility, molar volume. If S is an entropy, find out the value of this derivative V into del S over del V at constant temperature. From the Maxwell relation, del S over del V at constant temperature, that is equal to del P over del T at constant volume. This is one of the Maxwell relations. If you want to refer Maxwell relations, you can go back and check the video of Maxwell relations. In this case, this is the derivative. If you know the value of del P over del T at constant V, then we can calculate the value of this entire term. These two derivatives are different. Both derivatives are with respect to temperature and pressure of volume, partial derivative of volume, but this is totally different. From the cyclic product rule, I can write one equation: del P over del T at constant volume, then del T over del V at constant P into del V over del P at constant temperature, that is equal to -1. This equation is known as cyclic relation, triple product rule. If you want to refer the details about this equation, go to the video of cyclic relation. If I rearrange this equation, del P over del T at constant V, then it would be minus 1 over del T at del V constant P, del V over del P at constant T. In this case, I know two partial derivatives of volume. One is this one and the other is it is reciprocal. I can apply the reciprocal relation and I can write in this way: del V over del T at constant P over del V over del P at constant T. So this is taken from the reciprocal relation. Now this is equal to beta into V, and this is equal to minus KT into V. So minus sign will be cancelled out and this would be KT into V. We know the value of beta, that is 0. There is no need to put the other values because beta is 0. So this entire term is 0. If this is 0, then this would be 0 and multiplied by V del S over del V at T, that is equal to 0. This is a final answer. If you like this video, please subscribe to my channel. Thank you very much.